Okay, I guess we can get started. Thank you all for coming. My name is John Funge. I work for a company called Knack, and today I'm going to talk about predictive human analytics. So there's a bunch of people involved in this. It's not just me. There's a whole team of us. A couple of people I'd point out is the CEO, Guy Halftek. So the idea of the company originally came about when Guy applied for a job at a hedge fund and was turned down for the job, and he felt that there must be a better way to go about hiring than the current process. So that was the original motivation for starting Knack. A couple of other people to point out is Christopher Chabris, who's our director of science, who wrote a New York Times best-selling book called The Invisible Gorilla and is a professor of psychology in New York. So we have like real science behind this stuff that I'm going to be talking about. And obviously there's a lot of people involved in this. And this is the current team. There's been other people as well, obviously, prior to this. So this is the sort of basic idea slide of what the problem is. This is the problem statement slide. So the funnel over here, this funnel here is meant to represent the hiring funnel. So if you've ever done any hiring, you know how this works. You have to source a lot of people, and then you phone screen people, you interview people, then you hire people. And of that subset of people that you hire, that small subset of that you hire, an even smaller subset actually turns out to be any good. So hiring is a difficult process. It's been shown, I think, that interviews are typically about 3 or 4 in terms of correlation with final performance of people who actually get hired. But they're the main tool that we use today for hiring. And obviously that's not great. And so the idea is, can we use machine learning, big data to improve hiring, make hiring better? And some of the motivations for that, obviously many companies view this in terms of like a filter that they want to get better quality people. But the way we like to think about it internally is that there's a lot of people out there who could be really great for a particular job, but they are often overlooked. Maybe they didn't go to a top school or something like that, but they would be a really great person for the role. And how do those people get noticed? And so one of the things about the technology I'm going to talk about is that it's a way for people at the top of the funnel who might otherwise be overlooked to be noticed. And companies are really interested in this because they would like their workforce to be more reflective of their customers. And that's difficult currently because they just don't have the resources to interview everybody who might apply for a job. So they typically filter based on things like school and things like that. And then they typically get a very range-restricted group of people that they tend to hire. So companies are very motivated by this, but they don't have the resources to do this manually. So therefore, can we use a big data machine learning approach to help with this problem? So what's the Knack approach? So there's 2 sides. The first thing to say is that we evaluate people through gameplay. So we get people to play games, and then we analyze their gameplay data, and from that we can tell enough about someone that we can use that for hiring. Yes, of course. Oh, sure. It's not on. This thing did fall off at some point. I had to like sort of wedge it in there.
Would you
see this thing is not, it keeps falling off.
Give me a second.
Okay, thank you.
Should be good.
Okay, thanks. Sorry for the brief technical interruption. So we ask people to play games, and that gives us insight into their personality that then companies use for hiring. So there's 2 sides of this. So there's the institutional facing side, where companies obviously want to use this technology, as I just mentioned, to try and find better people and people they might otherwise overlook. And then there's also a consumer angle, where people are just interested in learning about themselves, learning about their friends, seeing how they compare to their friends. And we're sort of exploring. So right now the money is coming from the institution facing side, but we're also interested in exploring that consumer facing side. So one of the things you may be thinking, well, why do you use games for this? Like, why would you use games why would you ask people to play a game? It's not necessarily to play a game. Like, what's the connection between the two? Well, before I go into that, there's a quote that's sometimes misattributed to Plato that says you can talk to someone for a long time and you will learn something about them, but not that much. But if you play a game with someone for 15 minutes, you can learn a lot about their personality. People's personalities really come out when they play games. And the other interesting thing is that it has very solid ties to the research, the academic research in the area. So if you look at, like, there's a lot of laboratory measurements that cognitive psychologists have been doing for a long time to evaluate people. And if you look at those experiments, they're kind of like very boring games. And the other observation is, if you look at games, they're actually like very poorly designed cognitive tests. So the idea was, well, why can't we put those together and make fun games that are also well-designed cognitive tests? Some other advantages of games. So what do people do right now? Obviously, people right now do assessment of people, and they typically ask people to do these self-report surveys. So they'll ask you, are you a wonderful person? Do you work hard? Those kind of things. So one of the problems with that is obviously impression management. People understand typically, or think they understand what those surveys are looking for, and so the insight is not behavioral. Whereas with games, you're getting a behavioral insight into the person's behavior, and you're capturing a very high volume of data, and that's an advantage. And the other thing is that so there's this notion when you play a game that you get into the flow of the game and you sort of forget the context. I mean, not always, but if the game is interesting and engaging enough, you can get into the flow, and then your true personality can come out, and you're not so anxious because you're just involved in playing this game. So several advantages to games. It's fun. So everybody, more and more people are playing like casual games. So more and more there is games are a part of everybody's lives. As I said, the signal you get from games tends to be very authentic and rich. And the other thing is that they have cross-cultural reach. So with the self-assessment tools, for example, you'd have to translate those. They might not be a cultural fit, but games typically don't have that problem, or they have that problem much less, or they're more easily to adapt. Like everybody plays games all across the world, and they're very cross-cultural and cross-international boundaries. So games seem like a good idea if you could pull this off. So in terms of some of the specific games, so one of the games we have is called Wasabi Waiter. This was the first game we wrote. Here it's deceptively pictured on an iPhone. It actually is a Flash-based game that works on the web. We are working on the port to the iPhone. So we do have a game that's available in the App Store right now called Balloon Brigade. So here's the URLs so that you could actually download it. But the better way is just to search for Balloon Brigade, or even better yet, just go to the Knack website. So which is, you have to remember, it's knack.it. So it's not knack.com, knack.it. And if you go there, you'll find links to these games. And you'll also find a link to an app it's still quite early, that app, but it will let you be able to log in and see what we refer to as your knacks. So the consumer-facing side of this, that I'll talk about a little bit in a minute, is that you get these things called knacks that represent your personality, a fun way to see your personality. So, after this talk, hopefully after, not during, feel free to download this game and try it.
You recognize the music pretty quick, huh?
Exactly. So the second part of this is so if I'm a hiring manager, the thing I see, so the workflow is that people would play our games, and then the hiring manager would see some sort of view like this, where you would see some people sorted according to their Knack score. So the default product we have, what it does is it gives you a Knack score based on a general professional signature. So we've collected data from typical people who, typical professionals, and then this is how you compare against those people. So it's like a sort of general Knack score. If you're interested in it, we also offer a model where you can build a custom model for your company, because your company might have specific things you're looking for. For example, maybe you're hiring sales staff and you believe that certain like extroversion or something like that is very important for sales staff. So you can build a custom model as well. But the standard model is you just use the off-the-shelf one, but then you would see something like this. And then you can drill into one of those to see a little bit more details. And this is what I was referring to here as the knacks. So if you download the mobile app I referred to, you'll see this view. You'll see your knacks. And one of the challenges we have there that we're still trying to work through is what we call these things, because we have a perception right now that for the consumer-facing side, take something like extroversion and introversion. People often associate introversion wrongly with something negative. So how do you label that to people? And so we've come up with some labels to try and make those sound very positive. But that's one of the things we're sort of working on internally right now, is what's the right way to label those things so that we give people the right impression of those knacks. So you can see this. So this basically provides some sort of insight into the data, and then the sort of knack score is one of the key things that people would be using in order to figure out whether they wanted to interview someone. I guess that's another important point worth mentioning. We don't expect that it's going to be the case that people play a game and get hired necessarily. This is going to be an additional input into the hiring process. So it might be people that you would otherwise have overlooked. You might want to speak to them on the phone, or it could be an additional input when you're trying to make the decision about do you want to hire someone or not. So in terms of the process of how we actually do this, the sort of big data side of it, I'm going to dive in a little bit on the wasabi waiter game. So, and you can play this too if you go to our website. If you go to the mobile app again, it's a little bit clunky right now, as I said, because we don't yet have the mobile version. So if you download the app, you can click on it and we'll email you a link, and then you can play on the web. But anyway, the point of this game, if you've played Diner Dash, so this game was inspired by a game called Diner Dash, and so you're basically a waiter and you have to manage a flow of customers. And one of the twists about the game is you have to, when you click on a customer, they'll have a facial expression, and you have to recognize that facial expression, and you have to select a dish that corresponds to that facial expression. And so that helps us measure social intelligence, for example. So this is a point worth making, is that the way we've designed our games, so this game was designed specifically to measure social intelligence from the top down, but then from the bottom up, you just see that most games are some kind of measure of intelligence and many other things besides. So there's this top-down game design aspect where we specifically created this game to measure certain things, and then there's this bottom up just from the data. Turns out you measure a lot of other things. So for example, in this game, you have to do a trade-off between, there's lots of customers coming in, so you have to juggle competing priorities. So that's illustrates a lot about a person's traits and personality. And the Balloon Brigade game that I mentioned earlier, that one was specifically designed to measure risk tolerance because it was designed based on a laboratory experiment. So the laboratory experiment, people would come into the lab and they would inflate a balloon, and the bigger the balloon got, the more money they would get. But then if it popped, they would get no money. So obviously you see some people come into the lab and they inflate their balloon a little bit and take their $1, whereas other people will try to go for the $100 balloon. And so what we tried to do in turning that into a game was we made the notion of water balloons, and you have to throw the water balloons at these fire guys. And so again, you'll see the similar kind of behavior. You'll see some people will throw lots of they'll inflate the balloon a little bit and they'll throw lots of small balloons, and then other people won't. They'll create the big balloons and they'll try and go for the big balloons that do more damage. So you see similar kinds of behavior emerging in the game as you see in these laboratory experiments. So that was the design target of this game, emotion recognition and sequence optimization, but we see lots of other interesting things emerging from the data as well. So in terms of the data, this is the data flow. So the game data, which we refer to as the raw features or the raw data, is the instrumentation in the game. So measuring how people behaved in the game, what did they click on, what decisions did they make, that very sort of low-level data. We turn that low-level data into features. So features are things like averages, for example. So for example, a raw feature might be, at this time, someone clicked on this person's, selected that this person was this kind of emotion, or they picked this kind of dish to serve the customer. And then a derived feature would be an example of the average number of times that somebody clicked on the correct dish, for example. So aggregated data. And then we do, I think fairly standard in the area, we do sort of factor analysis to try to condense that into a smaller set of more meaningful features, because one of the things we've discovered with our customers is that they don't just want recommendations on, hire this person or don't hire this person. They want some more insight into why. Why do I want to hire this person? Some sort of insight into these recommendations that we're making. So we distill the data into these more meaningful patterns. So for example, this person is a strategic thinker, or this person is very good social intelligence, and so then we can give some color and some flavor into why certain people are being recommended and not others. And then so once we have that, then we need labels. So the labels can vary. So for example, if a company is using as a label might be performance reviews. And so then we can build a model that can predict performance reviews from existing people's game data. Or it might be like retention that we're trying to predict, or it might be sales figures that we're trying to predict. So we need some kind of labels. And so then we just use the standard machine learning approach of building a model that can take the gameplay data, distilled into these more meaningful patterns, and then predict the labels for new candidates once we've built that model. So hopefully, does that make sense? Like, I think it's worth stopping just here to make sure that everyone's clear on the basic procedure. Okay, good. Yes. Yes. Oh, yeah. Definitely. So a typical scenario would be that a company would put an optional link on their hiring page, and the link would say something like, here's the, fill out the form to apply for this job. If you would optionally like to play this game, then this may be a great way to get noticed if you think you might otherwise not get noticed. Like if you went to Harvard or something, like maybe you don't want to play the game. Maybe you feel like your resume just stands out so much that people would notice you, but perhaps if you didn't go to a top school or something like that, it's a great way to get noticed. Or they may ask you to play as part of the hiring procedure. Yes?
You have the machine learning approach and it predicted these things. Did you generate a bunch of training data with your own employees to see if the performance matched up with the profiles?
Right. So I'll actually get to that a little bit. We actually we did a bunch of trials, a bunch of pilots to build up that data set, and so I'll get to that in a moment if that's okay.
Okay, great.
Yeah. So this is a slide just on the sort of underlying architecture that we used here. We rely heavily on Amazon, on AWS. So I previously worked at Netflix, and so I basically took a lot of the learning from there in terms of how to build highly scalable architectures. So we don't have any single servers. Everything is an auto-scaling group backed by a load balancer. And we break everything down into separate services that communicate and are sort of autonomous as possible. So that's the basic sort of philosophy. All the developers are responsible for the operations as well. So we have like DevOps, which I think is like very popular now in this area. So if you build it, you're responsible for running it. So that again creates like highly reliable architectures typically. And it's been generally very successful. So in terms of the three large services we have right now, so we have the website. The website is built on Node.js, and the mobile app is built on PhoneGap, now called Cordova. The mobile game we actually built using Unity, which is like a cross-platform game development engine, fast to do that. And the API deals with all sorts of things. It deals with the typical account management, logging in, registering, that kind of stuff. And then it also deals with receiving the logs and storing the logs. The games produce a lot of data, so there's a challenge in just making sure that we can receive all those logs and store them. And so again, we've relied on Amazon's services that they provide us there. We've used their simple queuing service, SQS, and we've used DynamoDB. We're a very small team. So this just lets us offload these problems for now. As we grow, we may bring some of this stuff in-house, but for now it's fantastic to have these services, these scalable services that you can just let Amazon, within reason, let Amazon, you obviously need to know how to use them, but you let Amazon deal with a lot of the scaling problems, and you can just set how much data you think you need them to be able to deal with, and they'll just scale things appropriately. So I'll talk a little bit more about the underlying technologies, and then we have the compute service that actually does the computation. We originally wrote that in Clojure, but we found that was hard to hire for. So we've switched to Scala. There seems to be a lot of momentum behind that in the community. There's good numeric libraries, but we're fairly flexible in terms of like people within reason. Developers will be able to use languages that they feel most comfortable with. Again, that's taking from the Netflix model of freedom and responsibility, so that developers can use the tools that they think are the best fit. We don't have like large mandated like procedures about what tools people have to use. People within their team can use the tools that they think are appropriate. A little bit more on the technology choices. I think I've mentioned this already, some of this. I think one thing that we do that is kind of weird is that we use MATLAB for a lot of the experimentation, and so we got to the point where we had all this MATLAB code for building models, and we wanted to go to production. So one thing we could have done is rewritten the whole thing, but in the interest of speed, we just used Octave, which is the free version of MATLAB, to run a lot of this code in production, and then profile it, and then find the bottlenecks and rewrite the bottlenecks in Java or Scala, and gradually migrate to those languages. But it's been great for us that it enabled us to very quickly move into production. But I don't know how normal that is, but it's worked out for us. So now I'm going to talk a little bit about some of the results to the question we had earlier about how do we test this stuff. So I'm going to talk about 3 case studies with some pilots we did, one at Shell, one at Bain, and one at NYU Medical School. And the format of what I'm going to talk about is going to be kind of similar, but I'll spend more time on the Shell one, and then the others will just be sort of more of the same. So I'll explain what this graph is. So the context for the first pilot was that Shell had this innovators program, and so what that was is that within Shell, anybody could, people could apply to join the innovators program. And then of the number of people who applied, about 30% were accepted into the innovators program. And then those people would suggest innovations, and then they would measure how they did. So they would see how many innovations did they suggest, how far did those innovations progress, did they graduate. So they had some way of deciding whether someone had been successful or not in this innovation program. So before they met us, their success rate was about 30%. So about 30% of the people that they let into the program ended up being successful. So that's meant to be indicated over here on the left-hand side of that line, where 30% of the people they let in are being successful, and the rest are not being as successful. So what we did is we had these people, we had them play our games. We had 2 games that we had them play. And we used that data, and so we knew had this person been a successful innovator or not. And so then we used that data and the game data and those labels to build a model that was able to predict, was this person successful or not. And then Shell kept back a blind test set that they didn't tell us whether these people had been successful or not. And they had them play the game too, and then we had to predict, was this person, did we think this was a successful innovator or not? And then they revealed the answers, and it turns out we did really well. So the way we presented our results was we ranked everybody according to how good we thought, they would be as an innovator. And if you drew the line at 50%, so if you accepted the top 50% of the people that we suggested were going to be good innovators, then it turned out about 60% of those were actually good innovators. So we doubled their current base rate if you selected at 50%. But depending on how many people you have available, like what the flow is like, you can be much more selective if you want. So if I have like 1,000 people applying to a job, then I could decide I just want to take the top 20%. So if I took the top 20%, now I found out that over 80% of those people turned out to be top innovators. So it was nice to see that our ranking corresponded, that as you became more selective, a higher and higher proportion of people ended up being in that top performance category. So Shell was super excited about this. Here's some, I don't expect you to read them right now, they're on our website. And there was an article, there's been, as you can imagine, journalists enjoyed it, loved this stuff, so there's been quite a few articles about what we're doing. And so this was a quote that the person we worked to at Shell, and you can read this, there's a link to it on our website. So basically they were super happy with the fact that we were able to spot these people who would be good innovators in an automated way, because they wanted to scale out this program, but they didn't have the resources to interview every single person who, if they just opened it up broadly to anybody to apply, they just didn't have the resources to evaluate all those people. And they were, as I said, they were only getting about 30% correct anyway. So they were excited about this possibility. And the other thing to say is that going into this study, we had some intuition that maybe creativity was an important facet for being successful in this kind of program. And one of the things that came out of the data, which made sense after the fact, was that actual social intelligence was a very important factor. And when you think about it, that kind of makes sense, because if you're working in a large company, your ability to push an idea through the organization has as much to do with the social engineering as it does with the quality of the idea. So it kind of made sense that the people who were being successful in this program, it's not just that they were coming up with great ideas, they were able to push them forward. So that was nice, that sort of, we didn't think of, maybe we should have done, but we didn't think about it in advance, and it just sort of came out of the data and it made sense. So here's a similar kind of idea. So this was a study we did with NYU Medical School for selecting surgeons. And an interesting thing, I have a friend who's a surgeon, and he told me that they often actually ask people already in interviews about their game playing experience, because if you're academically brilliant, it doesn't necessarily mean you're going to be a great surgeon. Like hand-to-eye coordination is just like an important thing if you're going to be a great surgeon. So it actually he told me this afterwards, but it actually sort of makes more sense in light of that games would be an effective way of evaluating whether people would be good surgeons or not. And so it was the same kind of idea. They had an existing group of people, and that existing group of people, they had a way of evaluating did they make good surgeons or not. And so then we had these people play our games. So we had good surgeons, people who were not so good surgeons play our games, and we were able to build a model from that gameplay data to predict whether someone will be a good surgeon or not. And again, it's a similar kind of story. There's their current base rate, and then depending on how selective we are, so if we put everyone in order according to like how good we think people are going to be, and then we make the cutoff more and more selective, then you see a higher and higher proportion of those people in the group that is selected ending up being predicted to be good surgeons and actually being good surgeons when we pull the covers off and actually have the label. So that was an exciting result. Again, they were pleased. They were pleased with that. The final one is a similar kind of story. So this was a study we did with Bain for management consultants. And so they obviously interview people right now. They have some procedure where they try to decide, are they going to hire this person or not. And it turns out that they get about half of the people they hire turned out to be what they subsequently classified to be high performers. So again, we got these two groups of people, high performers, low performers, to play the game. From the gameplay data, we were able to build a model to predict this, and a similar kind of result emerges. So if we put the cutoff at 50%, we do slightly better than they are currently doing. But the great thing about Bain is they get so many people applying, and they get people applying from all sorts of different backgrounds. And so if you make the threshold much more selective, like if you only select the top 25%, now you're getting a much higher proportion of high performers. And the other thing that was very gratifying about this is when we built the model, so Bain ranks people at, I forget the exact what they call it, but they basically have a scale from like 1 to 4 or 1 to 5 or something like that. But we just decided to split people into two buckets because of the amount of data we had. So we just classified people as high performers or not. But the nice thing was that in the high performing group, as you became more selective, you actually saw more and more of those people that actually got the top rating. So even though the algorithm was not given knowledge of the fact that this person was a 4 versus a 5, it was picking up on something that was real, in the sense that as you became more selective, you saw more of the 5s in the more selective group than 4s. So that was something that we felt was very gratifying as well. So to sum up, we're excited about the way things are going. We really believe that games are a powerful tool that people could use. Games combined with this big data, machine learning. We think that this is a powerful way a better way of selecting people. And we're excited about other opportunities in education, college selection, those kind of things, not just hiring. I've shown you some of the early adopter results, which are encouraging. And we're now seeing strong customer uptake. And a nice thing, I think when we started this 2 or 3 years ago, there was a fair amount of convincing when companies came to us, and that's why we ran these pilots, and to try and show them that it works. But now we're discovering that people are not even asking us anymore, like, does it work? They've read about it, they've seen the other studies, they just like, where do we sign up? Like, they realize they have a problem with recruiting, and so they just want to, like, how do we get this? So we've just got a tremendous amount of inbound interest, and we're just sort of trying to scale up and cope with that interest currently. And as I said, if you want to learn more, there's some more information on the website. So there's plenty of time for questions.